So welcome back to example 2, which is -3 cosecant of the quantity 2x plus 1. And to sketch the transformations of this cosecant graph, we need to start with anchor points from the parent graph. And cosecant is the reciprocal of the sine, so we'll go ahead and start by sketching our sine graph. And sine goes between positive and -1 on the y-axis, and then we'll put our quadrantal angles along the x-axis. So this would be pi over 2, half the circle is pi, then 3 pi over 2, and 2 pi is 1 full rotation. So starting at the origin, we would have a 0, then a maximum, a 0, then a minimum, and then a 0. And sine, I'm just going to real lightly dash that in to see where it is, because I'm not trying to graph the sine, I'm trying to graph the reciprocal of sine, which is the cosecant. So remember that anywhere that sine has zeros, cosecant is going to have asymptotes. So I'm going to have a vertical asymptote here along the y-axis, then at pi, and another vertical asymptote at 2 pi. And then the absolute extrema of sine become the relative extrema for its reciprocal cosecant. And so I'll go to those maxes and mins and use them to flip these U shapes upside down. And that would be my parent graph of cosecant. So starting at the origin, where x is 0, the y at 0, because there's a vertical asymptote, is undefined. So we put a 0 with a slash through it for the empty set. Okay, then at pi over 2, I have a relative minimum of positive 1. At pi, there is another asymptote, so that's undefined. Then 3 pi over 2 is a relative max of -1. And then 2 pi is undefined. That's another vertical asymptote. Okay, so let's start by multiplying the y value by the a, and a is -3. That's our vertical stretch. Since the a is negative, there's going to be a reflection in the x-axis as well as a vertical stretch of 3, which will affect our amplitude. So all of these x values are going to stay the same, and then we're going to multiply the y times the a. Undefined times -3 remains undefined. Then we'll have pi over 2, and 1 times -3 is -3. Then pi and undefined stays undefined. And we have 3 pi over 2. And -1 times -3 is a positive 3. And then 2 pi and undefined. So that vertical stretch and reflection did not affect the asymptotes, only the relative extrema. Okay, now the b value is the coefficient on the x, and here the b is a 2. That's a horizontal stretch or shrink, and it's a positive, so there's been no reflection in the y-axis. So we're going to divide each of these x coordinates by 2. 0 divided by 2 is still 0. So that asymptote has not moved. Then pi over 2 divided by 2. Remember to divide means to multiply by the reciprocal. So that would be pi over 2 times 1/2 or pi over 4. Okay, then pi divided by 2 is pi over 2, and that's undefined. 3 pi over 2 divided by 2 is going to be 3 pi over 4. And then 2 pi divided by 2 is pi. And that's undefined. Okay, there is no h value here, so the h is a 0, and adding 0 to those x coordinates won't change their value, so we'll skip over that column and head on to the vertical displacement, and here the k is 1, so our vertical displacement is that this graph is going up 1 unit. So we're going to add 1 to all these y values. So the x stays the same, and undefined plus 1 is still undefined. Pi over 4. And then -3 plus 1 is -2. Then pi over 2. And undefined plus 1 is still undefined. So that's a vertical asymptote. At 3 pi over 4, 3 plus 1 is 4. And then pi is going to be a vertical asymptote. So we'll go ahead and sketch those asymptotes. We have one along the y-axis where x is 0. Then we have another vertical asymptote at pi over 2. And then another at pi. And we can see that these vertical asymptotes are all pi units apart. So these are going to be really tall, skinny U-shapes in between these asymptotes. Then pi over 4, we have a point at -2. So this first U-shape comes between those asymptotes and through that relative maximum. And then at 3 pi over 4, we're going to go up to 4. And that will be our U-shape between those asymptotes. So we would continue this pattern then in both directions. With alternating U-shapes followed by asymptotes in between. Here we have a vertical stretch of 3. The negative is a reflection, so we don't include the negative when we're talking about vertical stretch. The asymptotes are located at plus or minus k times pi over 2, where k is an element of the integers. A phase shift, since the h was a 0, there is none. The period is 2 pi divided by the b, and our b is a 2. So 2 pi divided by 2 leaves a period of pi units. The domain is all real numbers except those asymptotes. So the domain is x's that are not equal to plus or minus k times pi over 2. The range is bottom to top, so starting at negative infinity, we rise until we reach this relative maximum of negative 2, and that's inclusive, so we use a bracket. Then we need a union, and we're going to pick back up again at the relative minimum of 4, and then off to positive infinity. So our extrema, we have a relative min of 4, and the first non-negative minimum occurs at 3 pi over 4. Plus or minus k times the interval to the next relative minimum, and that is pi units. So k times pi, the period. And then our relative max is a negative 2. And our first non-negative maximum is at pi over 4. And then the interval k times pi, where k is an element of the integers. Okay, so go ahead and try this example on your own in your notes, and then resume the video when you're ready to go over the answers together. So anchor points on the parent graph of secant are 0, 1, and then pi over 2 undefined, pi, negative 1, 3 pi over 2 undefined, 2 pi, comma 1. And then we're going to multiply all those y coordinates by the a, which is a positive 2, and that a is also our vertical vertical stretch of 2. So while the y values are updated, the x's stay the same. Okay, then we're going to divide each of these by the b value, which is a 1/2. And when you divide by a fraction, you multiply by the reciprocal. So we're going to be multiplying each of these x coordinates by positive 2 to get these new points. Then the phase shift is the h value, and that's a 0. There is no h, so we're going to skip right over that one and go to the vertical displacement. And the vertical displacement is the k, and that's a negative 1. So we're going down 1 unit, which gets us these transformed points that we're going to sketch on the graph. So there was no phase shift. We have a stretch of 2 and a vertical displacement down. The period is going to change because of this horizontal stretch of 1/2. We're going to end up taking the period 2 pi divided by 1/2, which is a period of 4 pi. So these are going to get stretched way out when we sketch these anchor points. So we can see that the asymptotes now have changed. Our first non-negative asymptote is at pi plus or minus k times 2 pi units to get to the next. So that would be pi plus or minus 2 times, or k times 2 pi. Then the domain is going to be all real numbers except those asymptotes where the function is undefined. And our range is -infinity to -3 inclusive union, and then 1 inclusive up to +infinity. The relative min is a +1, and that's where x is plus or minus 4 times k times pi, or k times 4 pi. Y is -3 for the relative maximum, and our first non-negative maximum is at 0. So that's going to be, or sorry, at 2 pi. That's going to be 2 pi plus or minus k times 4 pi.